Greetings, this is Yingchen Zhou with Ian Bauer, Luke Foltz with Abigail Kobeck. Our presentation today is on annual muon modulation from the xenon1t experiment. This project aims to measure an annual muon modulation of the muon flux through the xenon1t dark matter experiment, specifically in the water tank muon veto system surrounding the detector. Muon events are counted over an entire year and weighted by the amount of time the detector was on. The relationship between muon flux and time will then be compared to atmospheric conditions, specifically the atmospheric temperature. We expect a direct correlation between atmospheric temperature and the flux of muon detected. Muons detected on Earth are produced by cosmic ray collisions into each other, producing a pion. If the pion did not collide with any other particle, the pion would decay into a muon and a muon neutrino. An annual muon modulation of these muons have been found to correlate with seasonal variations of the temperature in the stratosphere, shown in Figure 1 below, provided by Gerda experiment. The top graph of Figure 1 shows the muon flux over the time span from December 2010 to July 2013. The middle graph shows the temperature flux of that period, and the bottom graph shows the muon rates over temperature ratio of that period, respectively. It can be seen in the Figure 1 that there is a positive correlation between the temperature flux and the muon flux detected by the Gerda experiment. The Gerda study mentioned that when the temperature is higher, the air density is lower, therefore resulting in fewer pion collisions, therefore increasing the chance of a pion decaying and producing a muon. For this project, we hope to measure this pattern with data from the xenon1t experiment. The data using this experiment are muon events detected by 84 8-inch photomultiplier tubes in the xenon water tank. The graphs shown here in Figure 2 and Figure 3 are histograms corresponding to the T-star, which is the start time of an event for 2 different months recorded by the detector. Initially in Figure 2, we observed a strong drop-off in events after June and July, which had perplexed us. We then took the T-star values from May, which is before the drop-off, and September, which is after the drop-off, and created a histogram as shown in Figure 3. Figure 3 shown that the counts didn't change appreciably from before to after a drop. This implies that the issue with the drop-off, as can be seen above, was just an issue of the length of the runs and not with the total number of events recorded per run. Run times become shorter around halfway through around June and July, with many fewer events per run recorded, which led to the drop-off in events recorded, as can be seen in Figure 2. The Figure 3 graph shown that the total number of runs recorded remained unchanged before and after the drop. Temperature data are collected and analyzed to be used as a comparison to the muon rate. Figure 4 is the temperature data of 2 different weather stations in Italy. Initially, we had the daily room temperature data, which was then grouped into groups of 10 and found the average and the standard deviation for each group, showing the graph by black data points. A best fit sine curve was fitted to show the relationship between the time of the year and the temperature. With a newly obtained weather station, Pescara, that is much closer to the xenon1t experiment, but we were only able to get the monthly average and their standard deviation. Pescara data are shown in the graph by red data points in Figure 4. Pescara's yearly temperature fluctuates a little less, and it is more moderate due to its location on being on the coast. For future planning, there are 2 objectives we would like to achieve: calibration run removals and detector lifetime calculations. For calibration run removal, we obtained a list of calibration run times. With no information regarding the characteristic of the water tank data, the procedure could be done to remove calibration runs from the dataset, thus vetoing irrelevant data. As for lifetime calculation and muon rate, after the removal of calibration data, the final dataset will be used to calculate lifetime and the muon rate. We're hoping that the positive correlation between muon rate flux and temperature flux could be observed at the end of this project.